oxidation reduction and half equation. Oxidation reduction. The old concept of oxidation reduction is about substance who gain or lose oxygen. And this concept been expanded. Now the new concept of oxidation reduction is talk substance who lose or gain electron. So now under the new definition, oxidation reduction is talking about substance lost electron. Reduction is about substance who gain electron. Its focus is on electron now. Repeat. Oxidation about substance who lost or give out electron. Reduction is the substance who receive or gain in electron. Oxidation reduction, basically it happens in all chemical reaction. Why? Because in all chemical reaction, they must have some electron transfer or electron movement for a chemical reaction to happen. Without electron movement, chemical reaction will not happen. So, oxidation reduction is simply applied to most of the chemical reaction case. Oxidation reduction in periodic table we've been come across. Metal give electron is oxidation. Metal give electron is oxidation. Non-metal gain electron is a reduction. Non-metal gain electron is a reduction. Half equation. Half equation. Half equation is in the equation I break it in half. Of half belong to oxidation which lost electron. The other half is on reduction which gain electron. To split up half equation, we focus heavily on the top number, the charge of the molecule. And based on this charge number, I will identify and to split the oxidation part into half as follows. And then I will identify and I split the reduction part into half. And this is the half equation writing format. And as I mentioned, we are heavily rely on this charge number. We rely on this charge number to determine, to identify, and to split. And now I'm going to talk about how do we giving this charge number. This charge number is based on a simple rule called the oxidation state. Based on the simple oxidation state rule. The point of this oxidation state rule is to allocate the charge number. And now we start. On oxidation state, they break up these four rules. It divide into element. What is an element? Element like here, sulfur, it is an element. Oxygen, an element. Pure one form is an element. H2, element. Copper, element. So, element, pure one form. no matter you are diatomic, you're still an element. The next, iron. What is an iron? Ions is the ones that you see the charge. Here you see the 2 plus, you see the plus, minus, 3 plus. Iron have charge. Remember, iron have charge, positive ion or negative ion. And besides of element, ion, the next rule very simple. Molecule. What is a molecule? Molecule is more, 2 type or more combined. SO2, copper oxide, H2O. This is a molecule. The rule is, first you ask, is it an element, or is it an ion, or is it a molecule, to identify, number 1. And then rule number 2, we look onto the charge. In case if this is an element, the element charge always 0. Look at sulfur. The charge number are 0. Oxygen, 0. Hydrogen, 0. Copper, 0. So the charge number always are 0 when you are element. Rule number 2, charge. Charge, you just do exactly the same charge that it's given you. You see, for example, the charge in iron, 2 minus, 2 minus, 1 plus, 1 plus, 1 minus, 1 minus, 3 plus, 3 plus, follow the same charge. Oh, hey, how come this one's 0? Look, this is not an ion. This is an element. The element rule is 0. Okay. Now we go to molecule. Molecule rule, if you have any element, any molecule, you attach with oxygen. Oxygen always gain 2 electrons. Always. As see on the group 6, you need 2 more electrons. So you see, whenever, like on the first example, sulfur dioxide, oxygen always will be 2 electrons, 2 minus. So what happened to sulfur? To balance it off, you need to be plus 4, because minus 2 times 2 give minus 4. To balance this molecule out, S must be plus 4. Copper oxide. Oxygen minus 2. So copper must be plus 2. Water, H2O. Oxygen minus 2. H plus 1 and 2 times plus 1. So now this molecule balance. Now look at Hg. Oxygen minus 2. So Hg must be plus 2 to balance. And same as the more complex molecule, we have to work it out. As in this case, we will talk about that rule later. And same as H2O. So remember, any molecule attached with an oxygen must be minus 2. Hydrogen. Anything attached with a hydrogen plus 1. Typical example, H2O. H, whenever you see the molecule have a H in it, must be plus 1. And it's like HCl, H must be plus 1. What happened to Cl? There must be minus 1 to be able to balance. And this is the oxidation state rule. You need this rule to work out the charge number. Please remember, you need to have this 4 rule to work out the charge number of the molecule or element. And now I'm going to show you how we're going to use this oxidation state rule to do the half equation. Okay, now let's take an example. Magnesium with oxygen form magnesium oxide. Also keep in mind, you see the front number. This front number purpose is to do the balancing, but it does not take part in this reaction on oxidation and reduction allocate charge. Okay, now let's see. Magnesium, this and oxygen. This is our element rule. Element rule must be 0. Magnesium oxide. This is a molecule. Molecule rule, you have an oxygen -2, magnesium 2+. You see, I did not take this 2 into consideration to allocating the charge. Okay, now once we work out the charge by this oxidation state, now we will link it together. We link the magnesium with magnesium, oxygen with oxygen. We link them together. And now is a tiny rule you have to learn. And here you see on the corner, that is a rule. Let me blow it up. On this rule, you say if the charge number go up, 0 go to +1 or +2 or +3, whenever the number go up, oxidize. If the number go down from 0 to -1 or -2, that is reduce. You are reducing the charge. And student, please remember this addition rule. By applying to this rule, magnesium Mg0 to Mg2+, you are going up oxidation. Oxygen 0 to -2, you are going down. You are reducing the charge. Okay, once we work this out, we can use it to split. Let's do the oxidation first. Now, oxidation. Now you copy down the oxidation part. 2 mg, and on the other side 2 mg, and you copy down the charge and copy down the charge on the top. Reduction, copy down O2, you copy down O2, and on the other side copy down O. Hey, how come this is only 1O or 2O? Should be 2O. How come 2O? Look, this is 2O, not 1O. So if you copy this, if you only copy this part, you will be wrong. You will do a wrong balancing. So remember, now this is 2O. 2O. And then you copy the top, which is the charge, and now this is completed. Now you allocate 4 electrons. How come 4 electrons? Because 2 plus times 2 give 4 plus, so you balance it by 4 electrons. Now on this side, it gives you 0, and this side gives you 0. Be careful. This is very tricky. Now we do the next bit. On reduction, now you add 4 electrons. So you add 4 electrons. Now you see on this side, it gives you 4 minus. And how about this side? 2 times 2 minus, also 4 minus. Now, these two sides, they both balance. And then, these two numbers, they must be matched. Because it can't be, I give you $4, you only gaining $2. Then where's the missing $2? So these two numbers must be identical. And then you can do the next step. The same. You make sure gain electron. And now this half equation is complete. Now let's do another example. Carbon with oxygen form carbon dioxide. Combustion reaction. Now we allocate the charge first. Carbon, pure element, 0. Oxygen, diatomic, also pure element, 0. Carbon dioxide, molecule rule. O always 2 minus. So carbon is 4 plus. 4 plus. So now, once we done this part, what's next we do? Now we can link it together. Link carbon, link to carbon, oxygen, link to oxygen. And what's next? Now refer to, are they increase in charge or are they decrease in charge? Do the charge go up or do the charge go down? So carbon 0, it going up from 0 to plus 4. Oxygen O2 from 0 to 2 minus, so is reducing in charge number. Copper 0 to become copper 4 plus. Reduction. Oxygen 0 become oxygen 2 minus. Now we split it. Now next step, balancing with electron. The negative electron are negative. So this side you need 4. You need 4 minus to balance the other side. How about reduction? One side is 0. The other side is 2 minus. How you going to balance? Remember, this is oxygen 2 minus is not 2 minus. This is 2 times 2 minus. So it's 4 minus. How you going to balance? You need 4 electron. And now it will add up. So oxygen, you can see, is this side 4 minus. This side also 4 minus. They balance. So oxidation, the rule is it lost electron. Reduction, it gain electron. And now this half equation is completed. Now let's do one more example. This is a zinc with an acid. Metal react with acid, form salt and hydrogen gas. Acid reaction. Now we analyze it by half equation. Same rule. First, allocate the charge. Zinc, pure element, 0. Hydrogen, look at the end. Also, hydrogen diatomic, 0. HCl is a molecule. Molecule rule. H plus 1. Cl must be minus 1. The next one, zinc chloride. This 4 rule doesn't fit. But remember, zinc chloride Chloride always -1 on group 6 of the periodic table. Remember the iron that we learned, the iron charge, Cl 1-. So zinc must be 2+. Cl 1- times 2, 2-. To balance it out, zinc is a +2. Now, once we done the charge, now we can link it together. Zinc linked to zinc, hydrogen linked to hydrogen, chloride linked to chloride. Student, when you first look, you look very confused. It's okay, we take step by step. Look at zinc first. Zinc from 0 become plus. 0 to plus is going up in charge. Going up in charge. Oxidation. H. From plus to 0. From plus to 0, you are going down in charge. You are reducing in charge. Reduction. Chloride. -1 to -1. No change in charge. No change. Now we can allocate. Start off with the oxidation. Zinc 0 becomes zinc 2+. Do the reduction. 2H become H2. Okay? Now, how about chloride? This is a spectator. It still remains as -1, no change. So this one does not take part in oxidation or reduction. Now we go to do the electron balance. Zinc, you need 2 electron minus to balance out. As now you see, zinc this side on one side, 0, the other side, add together, 0. Student, I really recommend you, when the time you allocate electron, you better make a double check, because I see a lot of students make silly mistake by put the electron onto the wrong side. Okay, reduction. You also have to put electron. H is a +1, but remember this is 2H, so 2 times +1, so it's a +2. You have to have 2 electrons. Now you see oxidation, reduction. These two are the same, they match. That's the way we do half equation. Refresh your step. Refresh yourself the step. Step number 1, allocate the charge. Step number 2, link it together. Step number 3, to see are they go up. If the charge go up, it's oxidized. The charge go down, reduction. And then you will be able to split. Once you split, allocate the electron to balance it out. Okay, now we look onto the general picture. Okay, this lost electron, this gains electron. Let's look onto the general picture. The general picture say of these around 6 major chemical reaction. In this chemical reaction, if you have a close look, you know about half of it. Acid-base reaction, you know. Acid react with metal, you know. Combustion, you may also know. And all this reaction, you can write it into an equation form. And once you write into an equation form, you can use the equation form to help you to do the calculation. Are they solid, liquid, or gas to working in mole? And once you do that, you find that there is two ways of analyzing of an equation. One way is called ionic equation. Ionic equation. The second way is called half equation. So this is the whole chemistry structure. No matter you're on year 11 or year 12 or even future in uni, you will be on this. Or this is the whole picture of the way chemistry do analyzing. And what's anything special? When you look onto the equation, we care about the coefficient front number very much of the ratio relationship, because this ratio affect our calculation of mole very much. So we all care about, are they on the right ratio to the equation balance? Ionic equation, we care about the state change. Does this aqueous form into solid, or does this aqueous form into gas? So we care about the state change. Half equation. Half equation, we care about the charge change. Who give electron, who gain electron. By work it out and split half equation. We split half equation based on their charge going up or going down. Remember? So this is the way we analyze our chemistry. So today we talk, earlier we learned balance equation and we learned half equation. In the coming future, we will learn ionic equation. So I want to restate one more time. Oxidation reduction is not a one particular chemical reaction. Oxidation reduction talking about electron transfer. An atom give electron, another atom gain electron. And this happen to most of the chemical reaction. Could be a metal displacement, can be a metal acid reaction, can be a combustion reaction, can be a decomposition reaction. Any reaction, 90% of the chance, if you examine the charge closely, you will realize the electrons being changed, being moved. So please learn this topic well, and thank you.